Hey guys, this is our last set of notes for our little sequences and series mini unit. So we're going to be down here on slide 10 and 11 for geometric series. So at the top of your paper, go ahead and put your title. A reminder of what a series is. We talked about this last week. It's just the sum of a sequence. So if you add the first term with the second term with the third term with however many terms there are. So today we're going to be focusing on geometric series. So that means the pattern is multiplying by the same number over and over and over and over again. The formula we have is S sub n equals, it's going to be a fraction. On top is a sub 1 times 1 minus r to the power of n over 1 minus r. So what the pieces mean, S sub n is just the sum of n terms. A sub 1 is just your first term. Both r's are just the common ratio, the number that you're multiplying over and over and over again. And then n is just your number of terms. So you can find the sum of however many terms, 10 terms, 5 terms, 120, however many terms. We do have, with arithmetic, we could not find the sum of an infinite series. With geometric, you can find the sum of an infinite geometric series if your numbers are getting smaller and smaller and smaller and smaller, because eventually they get so minuscule that you're adding the tiniest little bit that it doesn't even really matter. So there is a sum for an infinite geometric series, and that is just a sub 1 over 1 minus r. You just get to forget about this piece right here. So this S is just the sum of an infinite series. Or infinite sequence. A sub 1 again is your first term. R is your common ratio. But this one can only be done, okay, only be done if r is in between -1 and +1. Okay, that's the only time you can do it. That just means that r has to be a fraction, the numbers are getting smaller. Over and over and over. Okay, we still have summation notation like we did with arithmetic series. It still looks the same. So remember, this is sigma. Sigma means the sum of. So we have n just tells you how many terms. Down here just tells you which term to start with. Again, this right here is just your rule. It has A1, the first term, and R, the common ratio. All right, so we're going to go ahead and do some examples of finding the sum. So write down examples. It says find the sum of the first 15 terms of the sequence 1, 3, 9, 27. So this is a geometric sequence because here the pattern is multiplying. So it's times 3, times 3, times 3. So our common ratio is 3 because that's what we're multiplying by. So our formula that we're going to use, we'll write it down again, is it's a finite, there's a set number of terms. So it's S sub n equals a sub 1 times 1 minus r to the power of n over 1 minus r. So we know our common ratio is 3. We need that. We also need the first term. Our first term is 1. And then we need to know our number of terms. That's 15. So I'm going to plug all those things in. The sum of the first 15 terms is the first term 1 times 1 minus 3 to the power of 15 over 1 minus 3. Okay. And we're going to have to use a calculator for that. So 1 times 1 minus 3 to the power of 15. So 1 times 1 minus 3 to the power of 15 does it like really nicely for us. So negative 14348,906. I wrote down on paper so I could come back to it. So on top was negative 14348,906, and on the bottom 1 minus 3 is just negative 2. So we're going to divide that answer by negative 2. I should be able to go like this and then hit divide by negative 2. There we go. So 717,4453. So the sum of the first 15 terms is 717,4453. That's 7,174,453. So a pretty big number. So we want to use our calculators. So it's going to be the first picture that'll go in on slide number 10. And we're going to go do one that's in summation notation. So go ahead and write down your example. The number on top tells you how many terms you have. The number 1 so this is not an infinite series because it's just a 5. This tells you you're going to start with the first term. That's good. So my first term is 5 and my common ratio is 2. And then we're going to plug them all into our sum formula. So it's just a1 times 1 minus r to the power of n over 1 minus r. So I'm going to go ahead and plug in my pieces. So s sub 5 is just the sum of the first 5 terms. A1, the first term is 5. 1 minus r is 2 to the power of 5. That's how many terms. So this number and this number are the same. Over 1 minus r, which is 2. Okay, so on top, I could probably do this one. Well, no, I'm going to need my calculator. 1 minus 2, that's 2 to the 5th. That's 1 minus 32 over 1 minus 2. So I get 5 times negative 31 over negative 1. Our negatives are going to cancel. So it's basically just 5 times 31. 150, 165. Was it 5 times 31? 155. So the sum of the first 5 terms is 155. So there's only 5 terms here. The first term is 5, and then the common ratio is timesing by 2. So it's 5 times 2 is 10, times 2 is 20, 20 times 2 is 40, 40 times 2 is 80, and that's 5 terms, and if you add them all up, you get 155. So you could just list them all out and then add them together. That's one way to go about it. All right, our next one is summation notation again, but if you notice there's an infinity symbol on the top. So this is an infinite sum, okay? You can only do the infinite sum if and only if this R common ratio is between -1 and 1. So it's a fraction or a decimal. 1/3 means you're dividing by 3. When you multiply by 1/3, your numbers are getting smaller. So check it works. We can do it. Okay. Hypothetically speaking, if you know, it was like this right here was a 2, we would just say cannot be determined. No sum exists. All right, so a sub 1, that's my first term, that's 99. R is my common ratio, that's 1/3. So I'm just going to plug those in. So 99 divided by 1 minus 1/3. I mean, some of you might use a calculator, but 1 minus 1/3. So if you had a whole and you took away 1/3, now you have 2/3 left. And then how do you divide by a fraction? Well, you change flip or multiply by the reciprocal of the divisor. So technically it's 99 over 1 times 3 over 2. So 99 times 3 divided by 2. So 99 times 3, 297. 297 divided by 2, 148.5. That's the sum of our series. All right, next one says, determine the number of terms in the geometric sequence. The first term is -2, the common ratio is 5, and the sum is -62. So we have our sum formula. The sum of n terms is a1 times 1 minus r to the power of n over 1 minus r. Okay, so it says determine the number of terms this time, right? So determine the number of terms. Well, we know S sub n is negative 62. That's the sum of however many terms. We know the first term is negative 2, and we know the common ratio is 5. This n is what we don't know. That's what we're trying to find. So I'm going to start off with the denominator. 1 minus 5 is negative 4. So I'm going to multiply both sides times negative 4. Then I'm going to go ahead and multiply negative 4 times negative 62. Oops. $248. Positive 248 equals negative 2 times 1 minus 5 to the power of n. All right, I'm going to divide both sides by negative 2. 248 divided by negative 2 is negative 124. I'm going to move over here. Negative 124 equals 1 minus 5 to the power of n. I'm going to subtract 1 on both sides to get negative 125 equals negative 5 to the power of n. So I can't divide by negative 5 and like cross it off, but I can divide by negative 1, and that's going to cross off my negative. So I get 125 equals 5 to the power of n. So I have to think to myself, 5 to what power is 125? Or I could do the loop trick and do logarithms, but we can probably solve this one off the top of my head. 5 to what power is 125? That number is 3. So there are 3 terms in the sequence that add up to negative 172. So the first term was negative 2, and then the common ratio was 5. So if you multiply by 5, you get negative 10. Multiply by 5. You get positive 50, negative 50. And when you add those together, you get negative 62. So there's only 3 terms. That's the answer. All right, so your homework is going to be similar problems. This goes on slide number 10 and 11 of your digital notebook. That's the last set of notes, so make sure you get them entered in. And that's it.